So here is our coaxial cable. We know it's an RG58 and we know its specs. Its characteristic impedance is supposed to be 50 ohms, but how can we verify that? Firstly, based on its physical dimensions and dielectric constant, we can use TX line in AWR to calculate its impedance. Indeed, it comes out to be approximately 50 ohms, but let's go one step further and verify it using both a virtual and physical VNA. The first step in this process is to measure the length of the cable, which turns out to be 100 centimeters. The length does not matter for the purpose of calculating its characteristic impedance, but it does matter when it comes to verifying it. Now we want to find the frequency at which this length is equal to 1/8 of the wavelength. Remember, our wavelength here is not that of free space. We have a dielectric between the inner and outer conductors, which slows down the signal's propagation velocity to 66% of the speed of light. So we want lambda by 8 to be equal to 1 meter. We need to set the velocity of propagation to 66% of c. And by rejigging the equation a little, we get the frequency that we are after, which is 24.75 MHz. So let's start with a virtual VNA in AWR. That's super simple, we just need to add a test port to our schematic. Then let's get a coaxial cable in. Set its inner and outer diameters and dielectric constant as per specifications. Then set the length to the one that we measured. And we will keep the cable unterminated, i.e. open-circuited. Then we set our test frequency to the frequency that we calculated. Set up an E1.1 measurement and simulate. Now let's place a marker right on this point. Change the readout to denormalized impedance. And here we have it, the modulus of the impedance seen by the port corresponds to the characteristic impedance of the line. Let's repeat this verification with an actual VNA and our physical cable. Here we are using an FPC, which can be operated both as a spectrum analyzer and a VNA. And this is the equivalent of our test port in AWR. Let's connect our cable. Then, insert a marker on the E1.1 trace. And position it at a frequency of 24.75 MHz. And there we have it! The imaginary part of the impedance is indeed very close to 50 ohms. The real part here accounts for losses, which are inevitable in any practical transmission line.